like this over on the west side, and one of them almost got burned down in the station fire. It came very close to it. Then we have two of them on the east side. And what this thing does, this interferometer, is they point these little telescopes at the same object, and they collect the light. And they touch the light down these tubes here, these aluminum tubes that have a vacuum in it. And you can see the aluminum tubes going across the road there. All the light from the different telescopes goes into a special room where the difference in distance to the star, because the telescopes are distance apart, has to be adjusted by super high powered computers, and it gets recombined. And it makes this telescope the equivalent of a mirror. That's the separation of all these big telescopes here. It's a fifth of a mile in diameter. There's no mirror anywhere near that size anywhere on Earth. So when this telescope looks at a star, unlike any other telescope where a star is just a point of light, this telescope sees the entire surface of the star like we're looking at the sun. It can see what's happening on that star. It can tell you the shape of the star, the temperatures on the star in different parts of it. And in about a year's time, I'm told by our astronomers here, they're going to actually be able to image planets going around other stars. It's going to be pretty profound stuff when that starts happening. So this is a really high-powered, cutting-edge piece of instrumentation here that's on Mount Wilson, and it's here for a very special reason. It's because the stillness of the air over this mountain is considered to be among the best anywhere on the North American continent. And it's because there's an inversion layer over LA, prevailing winds off the ocean, and that prevailing wind and that air mass glides right over the top of that inversion layer, and nothing can break through it and disturb it. So when it goes over this mountain, it glides very smoothly, so the images are very crisp. And with this kind of technology, you have to start off with good conditions to start with. If you don't, you can't really use this technology. This was either going to go here or it was going to go in Chile. And Georgia State University, who built this, decided to put it right here on Mount Wilson because of the incredible seeing conditions on Mount Wilson. So,
Is that because of our smog?
excuse me?
I'm just curious. Is
That's
that because of our smog?
Yes, that's exactly why. All the stuff that's down in the bottom that you breathe in Arcadia, if you work in the SO's office, none of that, or very little of that gets up here because of the inversion layer. So, yeah. So thank you for sucking all that.
Yeah.